All right, solving systems by elimination. Cancel something out, get rid of it. Get rid of one of the letters, then we just have an equation with one letter in it, and we can solve. Because if you got 4x plus 5y is 20, yeah, that's an x. 4x plus 5y is 20. There's lots of numbers we could put in and solve this. Not just one ordered pair, but many. We want one ordered pair that works in both equations. If you have one equation with two letters, x could be 5, y could be 0, and it works. X could be 0, y could be 4, and it works. X could be 1, y could be 16/5, and it works. X could be 1/2, y could be 18/5, and it works. And on and on and on and on and on. So, or like, x could be -5, and y could be 8, and it works. So, there are many, many ordered pairs that will work in this one equation. That's why when we graph it, we get a line. It would be something kind of like that. Infinitely many points on this line. A lot of things that make it work. We want to find the one that works in two equations if it happens. So, instead of having xy, 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 and a whole line of stuff, we just want one point. Like one time and one profit, or one time and one force, or one phase and one force, or something like that. Phase being like an angle. Engineers, some of them talk about the time domain and the phase domain, you know, where the domain, where the x-axis is time, where the x-axis is angle. But that's a little context for this stuff. So, some examples, elimination. So first, an easier one, kind of set up. We'll try 4x plus 8y is 20. Negative 4x plus 2y is -30. Okay. And we want to cancel out a letter. And remember, the idea we're using, as we said, a number plus its opposite is 0. Or a number minus itself is 0. But I'll focus on this, doing this more, adding every time. But a number and its opposite is 0. And we look at the coefficient of the things. So notice 4 and -4. A number plus its opposite is 0. So we have no x's left. If we have 4x and we take away 4x, gone. Or we have 4 and -4, they annihilate each other and gone. No x's. Then we add down 10y is -10. The temperature is 20, and it drops 30 degrees. It goes down to 0. Then just to go down 10 more. 20 and 10 is 30. So -10. Then we divide by 10. Y is -1. Okay, so we got that part. Now we need to get the x value. So pick an equation, put y in for -1. So I'll take the top one. So we have that. Y is -1. Y is -1. So in place of the y, I put a -1. So 4x minus 8 is 20, or plus -8 if you want. Then add 8. Then divide by 4, 7. 7, -1 is where these would meet. It's a thing they have in common, it's what they share. If we put it in here, -4 times 7 is -28. 2 times -1 is -2. -28 and -2 is -30. Check. Okay. Next. Oops. Number 2. Seven x plus 2y is 24. Eight x plus 2y is 30. Now we don't have anything that's equal but opposite, but we do have things that are equal. So look, these are the same. And now we need to work our own. We need to make them opposite by multiplying by -1. So I can get this one and multiply everything by -1. It's like distribute, and we get so I got this one and converted it into that. And I get this one, write it down here. Make sure we're not getting lost about stuff. So this one, I multiply, this one stays the same. Now, add. We're gonna squash them together, combine them, make one equation. Notice a number plus its opposite is 0, it's gone, squashed. -8 plus 7, -x, -1x, here, -6. This is like -1 times x. So we can divide by -1 or multiply. X is 6. So we got part of that. Then I need to get the y value. So I'll use the top equation. Remember, if you need a copy, stop, rewind, pause, whatever. So 7x plus 2y is 24, and we found out that x is 6. So we can put a 6 in place of it. X is 6. So 42 plus 2y is 24. Subtract 42. 2y is -18. Divide -9. Okay, so -9. 6, -9. Then if we check in the other equation, make sure I did my mental math right. 6 times 8 is 48. 2 times -9 is -18. 48 plus -18 is 30. Check. So there's another one where we had to do a little bit more on our own. Now, ratcheting it up a little bit more. we got guess I'll do that one. And then one down here. So I think we're on number 3. Unless I'm remembering wrong. So I'll do this one. 7x plus y is negative 19. Negative 7x. And negative 2x plus 3y is negative 19. Okay. So, whoops. Computer went to sleep. Screen's dark. Here we go. Okay. So now I can see it again. Notice nothing's equal but opposite. Nothing's even the same. We need to do that ourselves now. So it'd be easier to do here. It's 1y and 3. If I multiply 1 by 3, I have a 3. Then we have the same thing. 3y and 3y. And that's what we need to solve this. But I'll multiply by a negative 1. Or negative 3. Let's say, get this one. Because then we'll have a 3 and negative 3. We'll have a 3 and negative 3. And they make 0. Which is what we want. So, multiply by negative 3. Kind of distributing everything. 21x. Negative 7 times negative 3 is 21. Plus negative 3y is 57. Copy this one down. Because notice, these are equal but opposite now. 3 and negative 3. A number plus its opposite is 0. We've squashed it. We get these and squash them and put them together. Make a new equation. 21 negative 3, 57. Pop. Add down. 19x. And that'd be 38. Divide by 19. X is 2. So x is 2. Then we put 2 in for x. I'll take the second equation. We get this. X is 2. 2 is x. So we can get 2 and put it in place of the x. So now what we have left is the y. We have an equation with only one letter in it. That is our goal. So negative 4 plus 3y is negative 19. Add 4. Divide by 3. Negative 5. That is our answer. Is that awesome or what? And can put it in and make sure they work. Negative 2 times 2, negative 4. 3 times negative 5, negative 15. Negative 4 plus negative 15 is negative 19. Negative 7 times 2, negative 14. Negative 14 plus negative 5 is negative 19. So we are good. So, one more. Then we got to do on this next one the LCM thing we talked about before. Least common multiple. So I'll do this one. 3x minus 2y is 2. Five x minus 5y is 10. And remember LCM, least common multiple. Like if you get least common multiple, for example, before we do this one, before we do that, review this. Remember, least common multiple of like 3 and 7. Get the multiples of 3. 3, count by 3s. 6, 9, 12, 15, 18, 21, and so on. Multiples of 7, count by 7s. 7, 14, 21, 28, and so on. What's the first number they have in common? 21. So the least common multiple of 3 and 7 is 21. So these are multiples of 3 and multiples of 7. These are in common, and there'd be others, but this is the smallest of all the common multiples, so it's the least. So 21, that's an example. Now, that technique, that concept we'll use here, I get rid of the x this time. We have 3 and 5. I want to find the least common multiple of 3 and 5. So LCM 3, 5. Work it out, and you get 15. So I want to make each of these 15 so they're equal but opposite. And one of them will be negative. So how do we make this 15? Multiply by 5. How do we make this one? Multiply by negative 3. That makes 15. That makes negative 15. So we're good. Now, kind of distribute, kind of like 15x minus 10y equals 10. Negative 15x plus 15y equals negative 30. Okay, 15 minus 10 equals 10. Negative 15 plus 15 is negative 30. Then add down this and this, zero out, because they're equal but opposite. These are 5y, negative 10 plus 15, 10 plus negative 30, negative 20, divide by 5, negative 4. Now we need to get our x value. So pick one of the equations. I'll take the top one. 3x minus 2y is 2. But remember, y is negative 4. So y is negative 4. Ta-da. And then 2, negative 4, 2, there it's a little better. Then, when we multiply these, come in like negative 2 times negative 4, 3x plus 8 is 2, subtract 8, divide by 3, negative 2. Ta-da! Then we can make sure we're correct. So looking back at these, get rid of this so it's not confusing. 3 times negative 2 is negative 6. Negative 2 times negative 4 is 8. Negative 6 plus 8 is 2. Check. 5 times negative 2 is negative 10. Negative 5 times negative 4 is 20. Negative 10 plus 20 is 10. Check. So that's how we do these. And then see what you in particular might have forgotten, didn't learn, need help with. Maybe you need to practice your LCM. Maybe you're good at it and you don't. Maybe you need to practice with your integers. Maybe you're good at it. Maybe you're not. You know, you need to improve. But that's how we do that. If you got all the skills down, it'll be easy. And then again, just pick either the x or the y, make the coefficients equal but opposite, and then work it from there.